The first slide is really good because it tells us who our sort of sponsors are. So the whole area of greenhouse gas research could not happen without particularly the coordinating institutes, the PGGRC and the New Zealand Greenhouse Gas Centre, who do a great job in coordinating the research. But all of these people under here are the funders of the science. And these people here, including ourselves, are the deliverers of the science. And what we wanted to do today was really highlight what AgResearch has been doing in this space. We've been doing it for a long time. Ants, yeah, you've been pointed. So we have been doing it for a long time. And people still say to us, but you know, you've been doing it for so long, but actually, you know, haven't you got the answers yet? And we keep saying that actually we work in very complex biological systems, whether it's plants, animals, soils, or whether it's the rumen, which is the most exotic ecosystem you could find. It's really difficult stuff. But what we want to do today is talk about climate change is really happening. So particularly with New Zealand being a biological economy, really important around the variability in the weather patterns that we're seeing. And so droughts, the terrible flooding that we've seen, I think this is a slide from the Manawatu. Both of these types of events are becoming more variable, and they're also becoming more deep, if you like. And so this impacts on the way that we were going to do agriculture now and in the future. So the whole thing around greenhouse gas emissions is actually around temperature and the increasing temperature that's here we've got simulated, where here has been the historical simulation. This is the New Zealand warming compared to 1995. This is projected out way beyond, probably we're all going to be dead by then, but maybe not here. And here are two graphs, one showing a sort of a high emission scenario and what will happen to warming potential, and here a low emission scenario. I think the two things we wanted to point out was, even with the high emission scenario, we're really looking for those greenhouse gas mitigations so that we can reduce the emission intensity, which will then reduce the concentration of gases in the atmosphere, which will then reduce the global warming potential. And it's really that global warming potential that we're interested in. Even if we could reduce that greenhouse, increase greenhouse gas mitigation, we're still going to need to adapt. So it's not either or, you know, it's either mitigation or it's adaptation. It's both. We have to think about how we're going to manage both. New Zealand's emission profile is incredibly unique. In developed countries, the 80% of the gases are coming from energy and transport, 11% from agriculture and 9% from other. Compare that to the New Zealand profile, where 49% is coming from agriculture, 40% from energy and transport, and 11% from other. The fact that this is half of this is mainly because we use a lot of hydro. But this is the one that's of most important because we're a biological economy, and therefore that's why greenhouse gases from this combination is really important. So of that 49%, we've got 44% of those gases are carbon dioxide, 43% are methane, and 11% nitrous oxide with 2% other. And so the methane is coming from the ruminant of livestock. And given that New Zealand's agricultural economy is underpinned very much from ruminant livestock, that's why we have a focus on reducing methane. So, you know, again, why are we doing the science and where's it all going to end up? There's some areas here where we're interested in what we call the greenhouse gas inventory. Now, you'll hear about this from the speakers, but in essence, it's the annual accounting that New Zealand has to do back to the United Nations, which tells you the actual amount of gases that are leaving New Zealand. getting the emission factors right in that inventory or accurate for New Zealand is really important, because the UN and the inventory have default values. And so understanding how New Zealand's emission factors are in relation to that default can actually save us a lot of money. The on-farm accounting is very much about how will we find the hotspots on-farm, particularly for nitrous oxide and methane and carbon dioxide from an energy perspective. And so we work with Overseer, which in essence is a nutrient budget, but now has greenhouse gases in it. And we're looking to further develop the inputs into Overseer. And the third part that we're interested in is this whole idea of the carbon footprint. And so because a lot of our, in fact, 90% of the food that we're producing is actually being exported, it's really important for consumers to understand about the carbon footprint of that work. So consumers, you'll hear more and more, are interested in the sustainable production, and not only from the farm, but also right across the value chain. And so it's really important that we're able to demonstrate the carbon footprint of our goods in relation to other goods. So the targets that we have to meet are the greenhouse gas emissions. So 2005 is taken as the baseline, and the target that we have at the moment is 30% of the reduction below that 2005 by 2030. And then we're looking further to a 50% reduction by 2050. But as we do know also, the carbon zero bills around at the moment, and so carbon neutrality is another target. So this graph here is showing you the emissions CO2 equivalent. These are the years along here. This graph here is showing that this is the line where we would have been if we'd just done business as usual production. What we've got here is more animals, more intensity, and if we'd done nothing, this is where we would be ending up today. Now we're actually here at this point. Where we need to be is at this point here, and everything along that side. So and we need to be here. Now, I want to tell you two stories here. The reason that we're here is because of all the fabulous research done, and a lot by AgResearch, on making on-farm efficiency gains. Whether that's through reproduction of animals, so now we have less actual sheep numbers, but we've got more, you can get more lambs per ewe. Whether it's efficiency in the way that we use nutrients on the farm, the efficiency we use water, but those gains have been made by those on-farm efficiency. On-farm efficiency alone will not get us to this target here. That's why we need mitigations. We're not going to get there on our own by that. We've also got to think about our emissions not just at the farm gate, but right across the chain. And as I said before, consumers are particularly interested in how we're producing our food and what the environmental footprint of our food looks like. So when we're thinking about mitigations, we've actually got to think, how effective are they going to be in the whole scheme of things? Are they just going to shift you 1%, or are they going to shift you 20%? What are the other impacts that it might have, these sort of trade-offs? So we do know that if we're trying to reduce nitrous oxide in the atmosphere, we may inadvertently have more nitrate leaving and going into water. And so that's what we call pollution swapping. You're making one environmental area better at the expense of another. So we have to make sure that when we're testing the mitigations, that, what are the other impacts that they're having? A lot of the mitigations are individual, what we call components. So, for instance, it might be some sort of manure management system. But how does that fit within the farm system? And again, what are the cost effectiveness of being able to do that? And then, so therefore, what is the actual total impact that you're going to get when you come across these scales and you first enter the consumer's market. And we're doing this work with farmers and industry and processors and consumers. So we don't do science in a kind of little isolated silo. We have to work with these people. So here's just a little example of what I mean by the carbon footprint. So you can see here that's about lamb produced from the UK versus New Zealand. 85% of the carbon footprint of the life cycle is coming from on-farm, and that's mainly through those ruminants. Then we've got about 10% in the actual processing, and that's probably due in the main to CO2 and energy. And then about 5% in the distribution, which again is, we go by ship for most of our product, not by aeroplanes. And so when we come to explore the difference between the two systems, New Zealand has got its shipping added here, but because, again, we've got very good, efficient systems, we are actually producing per product our product at a lower CO2 equivalent. And you add on the shipping and you get up to 10. And if you look at the UK, it's actually just over, it's sitting at about 13. So that's the type of information that science can provide for our marketers, whether it's the dairy industry, whether it's the sheep and beef industry, to help market their product, to demonstrate that, in fact, New Zealand is okay in its carbon footprint, even although you may intuitively think it shouldn't. So AgResearch aims to work with the sectors and really helping to meet those commitments and to help in the reduction of greenhouse gas emissions. And we're doing that through 3 types of areas. One is that we're trying to improve the data that goes into the inventory so that it is New Zealand specific. And Jaffa's going to talk a bit about that. That we are developing different types of mitigation that can fit within a farm system, and you'll hear some of our work there. And then the whole area about looking at also the adaptation work that we're doing.